Okay, so let's continue what we were doing. So here I just changed the size of the disk, the light source, and I also just changed the position of the rays here. But otherwise, I haven't changed anything in the code. So now the plan here will be to first add a RenderCircle method in LightSource, in the LightSource class, because right now basically we only have this filled, so we just have a disk here. But at some point, maybe we will want to just have it be a circle, so hollow inside, or no pixels inside of the disk. And then we are going to add a ray vector in LightSource. So actually, let me just type here. So to do first RenderCircle in LightSource, or I'll just shortcut it with ls. Let's see what else we have to do. Ray vector in ls. Let's see. Then, I mean, we are going to have a ray vector in ls, but we are also going to have to render them. So a method like render rays in ls still. And once we have all that, if we have time, if we're done with these three things in less than 30 minutes, then let's check for collision with rectangles. So check for collision with rect objects. So let's do that. Where do we do that? We will see. Okay, so let's begin. So first thing will be RenderCircle in LightSource. So how are we going to do that? So let's go in LightSource and do a let's just do it right here. Void RenderCircle, and so we will take the render as always. Okay, and so let's do it right here. So void LightSource RenderCircle SDL renderer this way. Okay, good. Now let's see, so how are we going to go about this? Well, I think we're just going to take the same code as here, but we are just going to change the condition here. So if we make it equal here, does it work if we just make it equal? I have a feeling that it's not going to work as expected, because since it's not a perfect circle, it might not, I mean, since so the radius here is a double, right? But it's in reality it's an integer. In our case here it's 20, and this value here, so the square root of the power of the sum of the squares of I and j. I'm not sure that it's going to end up drawing a perfect circle. Like what I'm expecting basically here is to have something like, so normally we would have this, but here I'm expecting to have something like basically just many points, because since we are dealing with pixels, the distance is not perfect. It's not perfectly an integer. So we will have to see what we do about this. But let's, okay, so let's compile just to see if it runs. Okay, and now here, I guess we're going to do render circle, and let's see if this works. Right, so we only have 4 points here. So what I think I'm going to do is let's see, I can do a condition such that we take all the points that are let's see, so yeah, basically I'm going to do this. I'm going to draw all the points. So we have our axis here with the radius here, and we are going to draw all the points. So normally we would have a circle like that, but we are just going to check for all the points that are in a certain interval. So all the points that are here, from here to here, such that basically we're going to give a certain margin of error a certain margin to draw the pixels, and this way we're going to have more pixels. So, but this also means that it's not certain that we are only going to have a thickness of 1 pixel, but that doesn't matter. That's not necessarily what we are trying to achieve. We are just trying to achieve the shape of the circle. But if the length here is not exactly 1 pixel, it doesn't really matter. It's not perfect, but it should work. Right, so basically we want the distance to be, let's see, so how do we do this? So we want the distance to be, so this is, if we look at this distance here, this is basically, so this is below radius plus 1, and this is above radius minus 1. So below or equal to radius plus 1, and we're going to take the same thing. Let's do it here. Above or equal to radius minus 1. Why does it not work? Expected and expression are right. Oh, okay. Just put it outside, that's why. Okay. Let's see if this helps. Right, so we kind of get a circle, but as you can see, it's not perfect. Like in the corners, so let's make it a little bit bigger, right? Just so we can see it more clearly. 50. So if we look at so if we look at the corners here, like on the top left or top right, or here, you can see that the thickness is not exactly 1 pixel. So on this side it's exactly 1 pixel, it seems, but I mean, I think it does the job. I'll try to do some research online at some point and just look at how to draw a perfect circle using pixels. But yeah, so right now this is going to be enough for our use case. We're not going to be picky about it. So this works pretty well, it seems. Or actually, let's see, maybe it's better if we don't put the equal here. Let's just make it strictly above or below. Does it change anything? I feel like I feel like it's a bit more round, right? Like before it used to be a little bit more like a square. I feel like this looks a little bit better. I'm not sure, I might be wrong. But okay, let's keep it this way. So this is done. Done. So now let's create a ray vector in LightSource. So we have LightSource here. So for this we're going to have to include the vector library in our program, and let's put it here. So it's going to be an std vector of ray objects. Yeah, ray objects, and let's call it just rays. And so ray vector done. But so now we're going to do render rays. Okay, maybe I'm missing a method here. Maybe I should add first a generate rays method, and then in render rays I'm going to call it generate rays, and then I'll render them, so that basically my methods are separated. You know, I don't have too many stuff going on in only one method. But let's start in only render rays, and then we will see, depending on what we end up having. So LightSource, let's do void render rays, SDL renderer. This doesn't change. Right, so I'm thinking about something here. I should be able to make these methods const, right? since they don't change anything about the class. They don't change attributes or whatever. Did I make them const in the other class in Ray? I feel I got Ray here. Draw. Yeah, it's const, so I should be able to make it const. Make them const here. I feel like I'm not changing anything, so should make them const. But I'm just gonna have to add this to what I'm writing here. So render fill, render circle, and then render ray. Okay. So light source here. Const. Good. And so let's see. So how are we going to go about this? Well, so our light source has a radius, x and y, all that. So basically, let's remember how all of this works. So we have our rays. So we're gonna have our circle here, right? Let's go a little bit further below. So we have our light source here, and we want our rays to just come out from it here. So I'll just draw a few just for the sake of the example. Okay. And so we're gonna have this. So our rays, let's remember, they have 2 points. So the origin is going to be the center of our light source, and P1 is going to be the point on the edge of the light source. And so then when we draw them, they are automatically going to get drawn in this direction until the edge of the window. And then the color is just going to be the color of the light source. So no worries about that. Now, how are we going to basically distribute them equally along the surface of the light source? Well, that's a good question, but I just got another question. How do we know how many rays we should draw? Let's think about this. Render rays. Maybe we should add another attribute in light source, which we are going to call so it's going to be an integer, right? Int number of rays, just like that. And here we're going to add in the constructor, we're just going to add another attribute, which is another parameter, which is going to be int n. And then over here we're just going to initialize nb rays with n. Right. And so I'm not sure if I should initialize rays here with something that is empty. I think it is empty by default, so I don't need to initialize it here in the constructor, but we'll see. Okay, but anyway, it doesn't matter, because when we do render rays, actually, let me think about this. Rays. Yeah, so each time we do render rays, let's think about this. So when are we going to calculate the rays here? Like, when are we going to calculate their position on the circle? Do we need to calculate their position as soon as we create our light source, or not? Or can we simply always calculate them each time render rays is called? I think it's fine if we just calculate them inside render rays. Right, so I don't need to do it in the constructor. We're gonna try it this way, and if it doesn't work, it's fine. We're gonna change things. So let's add a number of rays here. Let's do it. Let's make it 100. And for now, let's see how to make this work. How we should make this work. So so we have the origin. The origin of each ray is going to be here's the center of the light source, and then we're going to distribute this over everything. And so what we know, so let's go in this direction, because this is the trigonometric, this is how it works in trigonometry. When we increase the value of an angle here, we go this way, not the other way around, not clockwise. So let's do it this way. And the maximum angle here, like we know we did a full turn when our angle has a value of 2 pi in radians. So let's do it this way. Basically, we're gonna have an angle of 2 pi, and so how do we know, like, so if we have to place 100 rays, how do we know how to place all of them? So we're gonna have 100 of them, like that. And so how do we know the angle between, so we want the angle between each of them to be the same, right? So basically, if we want the angle to be the same, it's going to be 2 pi divided by the number of rays. And this is going to give us the angle between each ray. Because once we have drawn all of them, the final angle of the final ray is just going to be basically number of rays minus 1 times all of this, which gives us number of rays times 2 pi divided by number of rays, which gives us 2 pi minus 2 pi, minus number of rays over 2 pi's. So if we look at this, so it's going to give us 2 pi minus 2 pi over number of rays, which is going to be basically something that is close to 2 pi but not exactly 2 pi. So I don't know if 2 pi is I don't know, like 6, let's just approximate it here. Since pi is about 3.15, this is going to be about 6.30 minus a very small value, so I don't know, like 0.02. And so this is going, if we look at the circle here, this is going to be this angle, right? Because we're going to go all the way here to here. This is going to be our angle. And so let's do it this way. So so let's create a double angle increment. Is going to be equal to m pi divided by so let's make sure it's a double here, and it's going to be m pi divided by number of rays. Do we have to, I mean, I prefer when I stick it, but I prefer when it's like this. Okay. And now let's see, for int I equal to, so let's start at 0, I below number of rays, I plus plus, what we're going to do is simply so we're going to create a ray here, so ray, and so what do we need to put in the constructor of a ray? It's a 2 points, just 2 points, okay, origin and point. And so we're going to put, so the origin is just going to be, let's see, our light source. What do we have as attributes? We have x and y, so this is going to be our origin. And now let's see, so the point where we're going to draw it, so it's going to be so the x value of it is going to be x plus radius times cosine of so I times our angle increment. Right, I think that makes sense. At least it makes sense to me. Does this work? What is it missing? No instance of constructor ray. Right, so we still miss the y value here, so it's just going to be y, and is it going to be plus or minus? I think it should be minus. So same reason as the last time here. It's the same reason as why we did here a minus here instead of a plus. It's because our representation is in terms in the y-axis is reversed. Instead it's like this instead of like that, and since we are going this way, we counteract the fact that we are like this by adding a minus in around the sinus here. I'm trying, I hope I'm making sense, but I mean mathematically it does make sense. And so I times angle increment. Right, and so this should be fine. Why does it not work? It should work. No instance of constructor ray matches this. So a ray is supposed to be 2 points, right? So okay, let's make this more readable by doing SDL point origin is just x, y, and actually let's just do this outside of the loop because it's always going to be the same. And here let's do SDL point P1 is going to be equal to this. So this and this here. And so ray, and now let's do so origin P1. Right, so this works. Seems like it works at least. Okay. So now we have our array. So we are going to render them. So what we need to do, like over here, is SDL set render draw color to, so we have the renderer here, and RGBA, just the color of the light source. Okay, sounds good. And let's see. So now let's see. We're also going to, so each time we render our arrays, we're going to have to clear our rays vector. Is it not clear? So let's see. What do we have here? Size empty. Let's see, so std vector empty returns whether the vector is empty. No, so it's not what I'm trying to do. Std vector clear removes all element from the vector which are destroyed. So why does this not work? So why does this not work, since if rays is a vector of rays, so why can I not do rays.clear? Is it, oh, it might be because I have a ray here, and so it, for some reason, yeah, right, so it might be because okay, so I think it might be because here our ray is not a primitive attribute, so it's a different class. So maybe we have to define a void clear rays, and we're just going to do it here. Light source clear rays, and let's see. So we can get rays size, right? Okay. Wait. Oh, I just got an idea. Std vector resize. Resize the container so that it contains n element. If n is smaller than the current container, size the container is reduced to its first n elements, removing those and destroying them. Right, so maybe what we can do, so I'm just going to leave clear rays right now in case it doesn't work, but we can maybe do rays.resize. Well, I can't. Why? Why can't I access it? Well, I'm getting a little bit confused here. So if I look at raise, I can do resize here, but for some reason I cannot do the same. Oh, my bad, it's because it's const. Right. I'm well, that's why you never make it const. I mean, that's why you need to think things through before taking this important decisions. Since I had made this method const, it meant that I wouldn't modify any attribute within it, but it looks like render raise, I'm going to actually to modify it, modify the raise attribute. So now we should be able to do clear, right? Okay, that's why it didn't appear. Pretty smart from those who wrote raise, to be honest. I mean, those who wrote the vector library. And now what we're going to do is simply add. So we're going to render the ray, of course. Render draw line. It's going to be ray. So it's going to be x1, y1. So origin. No. What am I doing? It's going to be ray draw renderer, and now we're going to do raise dot push back, and we're going to add the ray. Right. This should work. So we might go a little bit above 30 minutes in this video, but it doesn't matter if we reach 40 minutes, I think it's fine. Okay, raise the push back. I feel like this might already work. So I'll just delete this. I'll delete this. See if what we have here works already or not. I hope it does. Please. Okay, so we don't have anything. Why is that? Let's think about it. Is it because we didn't give a color to our array? We didn't give a color. But by default it should be white, so it should render. Oh right, it's because we didn't call the render raise. I'm not the smartest tool in the box, am I? Now here I'm just going to do render raise renderer. Right, and this is going to be the same issue if we make it const. So maybe I should just not make any of them const. This might not be some very great programming that I'm doing here, but I'll see later on if I should change things up to keep them const or not. I'm gonna check what the conventions are in graphics, but in graphics programming. But so render fill, render raise, renderer. Does this work? Okay, so we got a little issue here. Right, so I think I know what the issue is. Basically, so we drew from the angle started at 0, went to pi, and then let's see what is our function here. It's m pi divided by it's 2. It should be 2 times m pi here, shouldn't it? Let's see if this works. Ooh, that is very weird. Why does it do that? This is not great, is it? I times angle increment. I times angle increment. A point does take all of this. Oh, I forgot to add the radius here. Does this fix anything? I feel like it's not going to be enough, but oh, it is going to be. Oh, okay, cool, nice. So this works, but it's not the same color as the circle. So let's just do So here we're just going to do ray set colors is not maybe not optimal, but RGBA. Maybe I should just add it in the constructor of array to make it one line instead of two. But okay, let's try again. Right, so we just passed the 30 minutes threshold, but I think this looks pretty cool, and I kind of want to continue, so I'll just make this a little bit longer. So it does look like the angles are well distributed, although the one here on the right side is a little bit bigger than, a little bit smaller than the one here. I'm not sure why that is. I have an idea, but I'm not sure how to fix this. How can I fix this? Okay, let's see what it looks like when I make it a render fill instead. It should work, but let's just make sure. Right, so this looks like a sun. Right, that's a bright sun that we have in our solar system. So this is pretty cool, but here we have an angle that's not perfect. I'm not sure how to fix this. So we start I at 0, so first it's going to be cosine times there's cosine of 0, and here it's going to be sine of 0, which is going to be 0, so it's going to draw the first one perfectly. But when I is going to be equal to the half of nb raised, so nb raised divided by 2, it's going to be, so 2 times m pi, so it's going to be 50 times 2 pi nb raised, so it's going to, in our case it's going to be, let's go over to the side here, it's going to be 2 pi over times 50 over what was it, over nb raised, so over 100, which is going to be, so 2 pi over 2, which is going to be just equal to pi. So in theory, that's how it's going to work. But why isn't that the case? Why doesn't it do exactly that? Right, so I'll just try to do some short debugging here. Let's see. I'm gonna print. So I'm going to create another angle that I'm going to call A, and it's just going to be equal to I times angle increment, and I'll make another variable here called TA for theoretical angle, which should be just but technically it already is, but it's just going to be the same, but 2 pi divided by no, it's just going to be the same, right? So I'm not really sure honestly. I mean, it still looks really fine, that's for sure, but I mean, it looks fine, you know, like if I continue with this, I'm not going to be unhappy with it. It's just that here it's not exactly perfect, and it kind of stresses me. And the angle here is a little bit greater, so you know what? I don't want to waste too much time checking this. And look at the angle here. This is way too close, or is it normal? Is it because of physics? I don't know. But I mean, this looks pretty cool anyway, so you know what, I'll just keep it this way for now, and I'll think about it later on. If I have an idea, I'll change it, I'll apply my solution, I'll explain it in a video. Okay, so let's continue. So this looks pretty cool. So this is done. And you know what? Let's do the collision. So check for collision with rectangle objects. And so where do we do the collision checking? So let's see here. Check for collision with rectangle objects. So first thing obviously is that we're gonna have to draw some rectangles here. So SDL rect rect1 or like obstacle 1, and let's just draw a random one, like the coordinates are just going to be like 50, 50, 100 in height, and 70 in 100 in width and 70 in height. And let's draw another one, obstacle 2, which is just going to be I don't know, like let's put it around like 500, 300, and let's make it like in terms of width, let's just not make it very long, just 80 and 80 and let's see, like 200 in terms of height. Right, so let's do here SDL render draw rectangle, and I'll just put, or can I just do render draw rect? Yeah, I'll just make a basically an array of my obstacles, and here I'll just do SDL rect obstacles, which is just going to be so the length of 2 here, and I'm just going to add obstacle 1 and obstacle 2. Right, so this should work. And here I'll just do draw rects, so renderer obstacles 2. This should work, I think. Okay, so it drew them this way. I'm just gonna set the color here to make it different. So SDL set render draw color renderer, and let's just make them white. Right. Right, so this looks pretty neat. Should I make them filled or not? Let's keep them this way for now. And so now if I want to check for collision, I'm gonna have to check for collision at some point, but where am I going to do it? So I think I'm just going to do it within the render circle here. But in order to do so, I'm gonna have to pass the obstacles as an argument, and as well as the count, the number. So let's do it this way. So I'm gonna have to change RenderCircle in my class. So RenderCircle, and this is going to take in SDL rect obstacles and int count. Let's do it this way, yeah. Okay, and let's see. Now we're gonna have our obstacles, and so each time we draw so each time here we draw. Wait, no, that's no. I'm doing it in. I'm not going to do it in here. I'm going to actually do it in render raise. So I'm just going to pass these over here, and then in render raise, I'm going to change some things. So I'm going to change this. And where is it? Render raise. It's over here, right? So this should make it better. So it says that there's a red point here. I'm not sure where it is. I'm trying to look. Oh, right, it's here. And here, render raise, I'm going to do same thing. So obstacles count, which means I'm also going to have to change this over here. And I'm going to have to change it within the class also. Okay. So it's getting a little bit messy right now, but it's fine. We'll clean things up later on. And so, okay, good. We have all of that set up. And now what we're going to do is in render raise. So let's make some space here to make it a little bit more readable. So we're gonna clear it first, then we're gonna create our angle. Let's just put this here. Okay. And so when are we going to check for collision? We are going to check for collision over so we're going to check them over here, obviously. And so for each ray that we are drawing, basically we're just going to pass around these elements in through basically every method of every class. So basically in draw we are going to pass in obstacles and count. And now I'm just going to take this and take it to the draw method in draw, right? Draw, and here as well. Okay, and so I think that is where we are going to do that. So what does it say? That declaration incompatible with no. Oh, okay. And so if I do this, right, and now this is where we are going to check for the obstacles. So we have P2X, P2, So now what we're going to do is we are going to draw a line here. So we are going to create a line. How do I do that? No, we're not going to have to draw an artificial line. We're just going to have to do so in the API here. If we look at the API index, they have some things about intersections. SDL render intersect. No, so it's just intersect. Intersect rectangle and line. This looks good. And we're gonna have to pass in a rectangle. So a rectangle and a line segment. So we have this information. We also have these, which is here in what we passed in here. So it's going to just be a for loop here. So for can we just do obstacles? Oh right, I have to type it. Right, so because this uses an iterator, so it's not going to work. So for just int, so we can use I here, I equal to 0, I below count, I plus plus. What we're going to do is simply, pressed on the wrong button here, is simply check, so you're going to do bool collides equal false, and if SDL intersect rect and line between, so this is going to be it's going to be obstacles I, but the address of it, right? And so x1 is just going to be so what is the origin here? It's going to be, we are in the class, so it's just going to be origin, right? We can pass this. So origin x, origin y, p2x. Well, it's not origin actually, is it? Or it is origin. We are draw, and so it's origin and p1. No, so it's actually going to be p1, p1x, p1y, and here it's going to be p2y. So why does it not like it? Int. So what does this take? So it takes, so for some reason it takes in the address. Int x1, why does it do that? Const int. Incompatible with, why does it say that it's const? Because it might change it, is that why? I guess nothing can be constant in this world. Nothing is constant. Everything is always changing. Pretty sad. Okay, so let's do that. And if it is, then collides will be equal to true. And so maybe we should declare this collide equal to false, and here we'll do collide equal to true, and by default for every ray we are going to do collides equal to false, right? We're just going to reset it basically, and collides equal to false. Right, this might work already. Should we run it? I'm kind of unsure. Alright, so, ooh, wait, this works. Wait, this works actually. Oh, right, it works, but not the way I wanted it to work. We still have to draw the ray in like this length, right? So, what is this going to be? I think I have an idea here. So there's an intersection, right? And technically, since we already calculated this, then we know where the intersection is. So why is it not calculating anything here? P1x, P2x. Let's see, I'm kind of unsure here. I pointed to the ending, so calculate the intersection of a rectangle and a line segment. Right. Let's see. So collides becomes true, so we get out of the while loop. Okay, so let's think this through. So we are trying to draw a single ray. This might go over an hour actually. Pretty fun, honestly. But okay, so we have this going on. I mean, this works pretty damn well, honestly. Besides this small issue, honestly, it's pretty satisfying the way it looks. And alright, so we got some hair growing around our circle. It's pretty funny, but we can fix that another time. Honestly, it's not really like very urgent. Okay, so let's see. So we are trying to draw just an array here. We have a point distance, okay, and so first we set collides to false. So it's fair enough to me, honestly. And here we go through, so P1 is where the origin gets drawn originally. Actually, you know what? I have just a small idea here. Maybe I should start the distance to 1. It's not going to fix what I'm trying to do, but I just want to see what it does. You're right. So now we still have some hair on our circle. Okay, I'm gonna just fix this another time. Maybe I should just try at 0, distance 0. Right, so we don't have any more hair, it seems. I mean, we have some pixels here, but... Right, so let's see. What if I do like -1? This doesn't make any sense, but... Right, so we still have a little bit of stuff here. Okay, so you know what, I'll just keep it at 0. So, oops. Alright, so we got this going on. So let's think about it again. So we check if it's collision, we get our new point. So basically the new point is going to be so P2, what is P2? It's P1x. And what is P1? P1 is like a point on the circle, on the edge of the circle. And so P2 is just going to be, for example, like for this particular array, it's going to be, for example, here. Then we check if this collides with a rectangle, and if it's true, if there's a collision with one of the obstacles. Am I checking on the right coordinates? Yeah, I'm checking for P1 to P2. So if P2 is, for example, here, we're checking for the collision. And as soon as we see that there's a collision, so we say that it does collide, we say true. So we get out of the loop, set render draw color, set render draw line. And we draw it from P1x to P2x. I mean from P1 to P2. But why doesn't it draw it here then, if that is the case? Why doesn't it draw it here? I'm unsure. Why doesn't it draw it? So from P1 because we have a value, right, for P2, like P2 we know let's see, what else do we have here? If we say intersect rect and line, and so this should work. Do we have something else about intersections or not? So this is all we have. So this is the entire thing. So let's see. So is this all we have with intersections? Do we not have something else? Let's go to. So this is the entire API. Let's go to API by category. Let's check for pixel formats, rectangle functions. Rectangle functions has intersection. I had already checked it out before, but okay. So maybe what I can do instead here is just do a so maybe I can do here a rect that I'm going to call pixel, and I'm just going to give it the coordinates of so it's basically going to be P2x and just P2y and 1 1, and if there's if has intersection, two rectangles intersect, and so this is just going to be rectangle A and rectangle B, so this is going to be pixel. Then we're going to do that. Expected A. Alright. Okay. let's see if this changes anything. Right, so now this works. I'm not sure why the other one didn't work. If anyone's watching and anyone knows, then let me know. But so this works pretty damn well. I'm pretty happy about it. Let's put this here. Yeah, I'm happy with this. I'm happy with this. Okay, so this is how it looks. Now let's make them filled. Render fill and set render draw or fill rects here. Let's fill everything. Right, so this looks pretty cool. Okay, so I'm gonna stop this video here. It's 55 minutes long. Doesn't matter. I enjoyed every second of it. It was a pretty fun challenge. A little bit more troublesome than before, but okay, than the other ones. But it seems like it works. We have a program that's 188 lines long. Seems pretty fair. Not too long, not too short. So, okay. Now, what we're going to do in the next video is do the same thing for collisions, but okay, so I'm gonna fix this thing where my circle has some sort of hair on it for some reason. So like if I do render circle and here render draw rect, oops, like this for some reason has some little hair. I'm just gonna try to fix that. So it's going to be the next things to do. So fix hair on circle, on LightSource circle. Let's see, what else do we have to do? So collisions with other shapes, so like circles and all that. And then I mean, if we can just do that for the next video, I think that's pretty good. Maybe I should add something else, like, oh right, maybe I can make it create an abstract obstacle class. So why abstract? Well, I think I got it here. No, because I had looked it up just to talk about it a little, but basically abstract class C++ here, yeah, pure visual functions. Basically an obstacle is going to be either a rectangle, a circle, or any random shape, right? So if we have an obstacle class which is going to have a common method called get pixels or get shape or whatever, and then we're gonna have some derived classes. So if we look at paint here, we're gonna have obstacles here, and then we're gonna have a rect, circle, and whatever. But obstacle is going to have some methods that are going to be common to rectangle and circle to check for collisions and all that. But the way we're going to define those methods is going to be different from rectangle and circle. But since we're going to make rect and circle inherit from obstacles, I mean rectangle and circle classes, we're going to make them inherit from obstacle. Well, we will just be able to say, so if we have an obstacle called obstacle1, we will be able to write obstacle1 dot check for collision or something like that. And so I think we should do that in the next video, and if it works, that will be pretty cool. And then in the next video, we're gonna do reflections. Okay, so thank you for watching. I'm gonna stop here and see you for the next session. Right, goodbye.